In any piston-powered vehicle you've ever been in, whether it be an aircraft, a bus, a car, or a motorbike, there will have always been a device within the engine whose primary function is to combine fuel and air together. The combined mixture is sent into the cylinders for combustion to produce power to ultimately move you from one place to the other. These devices have been around since the first petrol-powered engines and come in a variety of different designs, but nearly all perform the same basic task, mixing fuel and air together. Since the first internal combustion engines, the simplest way of creating a correct fuel-air ratio is to use a carburetor. Carburetors were in use since the very beginnings of petrol-powered engines and only began getting phased out in the late 1980s due to the emergence of the more fuel-efficient and environmentally friendly fuel injectors. In light aircraft, however, carburetors can still be found as they can present many advantages over that of fuel injectors, like the ability to function without electrical power and their inherent mechanical simplicity. However, arguably their biggest disadvantage in an aircraft are their susceptibility to icing. The first type of icing we'll look at is impact ice. Impact icing occurs when supercooled water droplets enter the intake and form ice crystals on the metal components. Supercooled water droplets are water droplets that are still liquid below their point of freezing. The instant those water droplets have a chance to connect to a hard surface, the water molecules are able to form a strong lattice structure and thus freeze onto the surface. What this means is that along the front of an aircraft, air filter, intake tubing, and the throttle body, ice builds up, reducing the usable volume for the passage of air and restricting airflow into the engine. This has the effect of choking the engine of oxygen and disrupting the fuel-air ratio that enters the engine, both of which will lower the engine's power and increase the roughness of its running. Impact icing can occur when flying at temperatures at or below 0 degrees Celsius and when in visible moisture such as cloud, mist, or rain. Impact icing can also occur when an aircraft that has been colder than freezing, such as after flying at high temperatures, descends into cloud, freezing water droplets onto the cold metal surfaces. The second type of icing is fuel evaporation ice. As fuel is sprayed into the airstream of a carburetor, some of it will evaporate. As liquids evaporate, they have a strong cooling effect on themselves and the air around them, just like water or sweat, and the same occurs inside a carburetor. The cooling of the airflow can bring temperatures within the carburetor to below freezing, which has the effect of causing moisture within the air to quickly freeze onto nearby solid surfaces. Because of the nature of fuel evaporation icing, this can occur at nearly all temperatures, sometimes as high as 30 degrees Celsius when the relative humidity exceeds roughly 50%. Just like impact icing, fuel evaporation ice can seriously restrict airflow through the carburetor and disrupt the fuel-air ratio, dropping engine power and efficiency. The third form of ice is known as throttle ice. Throttle icing is a variation of fuel icing and is the term given to the formation of ice upon the throttle valve just downstream of the carburetor. Significant quantities of fuel ice can build up upon the throttle valve and body if left unchecked, which not only restricts airflow but can lead to the throttle valve being frozen in place by the surrounding ice, preventing you from being able to increase or decrease power until the ice melts or otherwise breaks free. Throttle ice is quite dangerous because of this, and, just like all forms of icing, should be avoided and remedied when possible. Most carbureted aircraft come equipped with a carburetor heat function. Pulling a valve in the cockpit will actuate a flap in the intake pipe, which allows air heated by the exhaust pipe to enter the carburetor in place of the air drawn from outside the aircraft. The heated air is then able to melt any ice that's formed on the intake pipe and carburetor barrel, as well as the throttle body and intake manifold. As the airflow is de-restricted, engine power returns until all of the ice has been removed. Icing can occur at almost any temperature, and it can range from 0 degrees Celsius to as high as 30 degrees. Icing can form the fastest in temperatures below 20 degrees when the relative humidity is above 50%. If flying a carbureted aircraft, it is important to look out for the symptoms of icing, low power and rough running while flying in humid conditions, and to apply the carburetor heat whenever icing is suspected to be forming.